Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled NGC 2170, the Angel Nebula. So what do we see here? Well, here we see what is known as the Angel Nebula, also known by its catalog designation of NGC 2170. Now, it may almost look like a painting here with the different colors that are present, but this is indeed a photograph of this region looking deep into this nebula. Now, within the nebula, we see three different types of nebulae that are present here, and they're represented by different colors. We see a blue color, which is a reflection nebula, the reddish color, which is an emission nebula, and the dark, dusty areas, which represent a dark or dusty nebula. Now, these three are all formed in slightly different ways. Let's look at the dark nebula first. So the dusty regions, that is a concentration of material, and it is tied into star formation, in fact, where the stars are just starting to form. Within those densest knots, a star or stars will be forming, and eventually will break out of that cocoon and be visible. But right now, we can't see them. Well, we can if we look in the infrared. If you take an infrared image, the longer infrared wavelengths will then allow you to see through the dust and to see the stars that are in the process of forming. But with an ordinary visible light photograph, such as the one we're seeing today, you can't see through the dust. Those shorter wavelengths do not penetrate the dust well. So that's the earlier stages. The later stages we see as the emission nebula. So an emission nebula glowing in red is leftover gas around a star, which is being energized by the hot stars that have already formed. So this is a later stage than we see within the dark nebula. Now the material has broken out. Those stars have broken out of their cocoons, and they are starting to energize the material around them. And that will excite the atoms and cause them to glow, just as we do in various gas tubes here on Earth for signing. You can put electricity through that gas in the tube, which will excite the electrons in those atoms and cause the atoms to give off photons of light of very specific wavelengths. Well, the same thing happens out in space, except instead of electricity going through them, it is ultraviolet light from those very hot stars that does the same thing. It energizes those electrons, excites them, and then the atom will glow because of that. And that will then give off this color. As you get billions upon billions of atoms doing this, we get the colors that we see here. Now, the third type of nebula that we see is the reflection nebula, shown in blue here. That is also a later stage of star formation, as the stars have already broken out, but here we're seeing dust around the star rather than gas. Dust, which is slightly larger particles, not as big as household dust that you may think of when I use that term, but just slightly larger particles than individual atoms or molecules. Those dust particles scatter the light around it and are much better at scattering the blue light than the red light. So they will scatter the blue, and the blue seems to come from all directions, but the red light just travels straight through. And that is one of the reasons, again, those longer wavelengths help us to see better into those star-forming regions because of the way dust scatters the light. So here we get to see three different types of nebulae: the dark nebula, the emission nebula, and the reflection nebula, all in this one region of space about 60 light years across, known as the Angel Nebula. So that was our picture of the day, titled NGC 2170, the Angel Nebula. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.